Good afternoon, class. Here's elementary statistics practice test number 1, module 1, covering chapters 1, 2, and 3. Here's chapter 3, describing, exploring, and comparing data. Here's the pledge, so I'm going to repeat it again. For every exam, I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam, or for that matter, any other exam. Unauthorized actions include, but are not limited to, the use of notes, text, search engines, PowerPoints, AI, or any other resources not explicitly allowed. For statistics, you may use formula sheet, tables, and a graphing calculator. The following data gives the number of hours that a few employees at the GM factory worked last week. Find the mean. So there are 18 pieces of data. I'm going to rank them from the smallest to the largest. However, it's important to know we don't need to rank data for some calculations, such as finding the mean. However, it's a good practice to do so for those calculations that need rank data. You see, for example, to find the median, the mid-range, the range, the mode, all of the above, ranking makes a difference. So you start with the formula, you have access to formula sheet, and X bar is summation of X over N. Remember, this is a sample because we are dealing with only a few employees. X bar is summation of X over N. So simply put, just add them all up from 14 to 42 and divide by the total size, which is 18. So you should know the formula. You may use a calculator. However, it's a good idea to, at the very least, write the formulas for partial. So that's the answer. And as far as the number of decimals, you always carry many, many decimals. And then you follow if they ask you to round it accordingly. Find the mode, the one that repeats with the highest frequency of occurrence. The mode, there is nothing that repeats. Therefore, there is no mode. Find the median. So simply put, the middle of the data, and that would be somewhere here. So you're going to add up 25 and 27 and divide it by 2. The answer is 26. Because n is an even number, when you want to find the median, there is no number in the middle. You add up these 2 and divide by 2. If n happen to be an odd number, there is one number in the middle. Mid-range, simply put, is the value midway between the max and mean, and therefore has the formula max plus mean divided by 2. So we're going to add the maximum 42, the minimum 14 divided by 2, and we end up with 28. What about the range? By definition, it's max minus mean, 42 minus 14. The answer is 28. Note, R, the range, and MR, the mid-range, are not equal in general. In this case, it happened by chance. So that's important to understand. Normally, it doesn't happen. It did happen here just by chance. All right, we're going to continue on that thoughts. And now we are going to look at the variance and the standard deviation. Bear in mind that we are dealing with a sample. So we're going to use the sample formula. I'm going to show you how we can do it by hand. And of course, you can use any type of a technology, okay, TI calculator, other types of calculators, Excel. So the formula is, as you can see, a squared summation of x minus x bar quantity squared over n minus 1. Or if you go with this formula, n, which is 18, summation of x squared. That means the first one, 14 squared, plus the next one, 16 squared, all the way to the last one, 42 squared, minus summation of x quantity squared, add them up, 14 all the way to 42, add them up, and then square it, n times n minus 1. And you come up with the answer, and it so happens it's extremely close to 75. Just to show you, if you want to go with this formula, x minus x bar, that means you start with the first one, 14 minus the mean, 26.9444 quantity squared, plus 16 minus that, 17 minus that, all the way to the last one, 42 minus that quantity squared. If you, and of course, divide by n minus 1, 18 minus 1. Either one gives you the same answer, and the standard deviation, you don't really have to do much, just take a root of this number. And again, as far as the number of decimals, you just follow what they ask you. The inner quartile range, by definition, IQR is Q sub 3 minus Q sub 1. IQR describes the middle 50% of values when ordered from lowest to highest, Q sub 3 minus Q sub 1. Clearly, we know Q sub 2, or the median, is 26. Now, the way you find Q sub 1, the bottom half, the middle term, it's called the submedian. Okay, the median of the first half. So we look at, and looking at this part, the fifth one, the answer is 20. And now Q sub 3, the second part, number 34. Again, is this the only way? No. This is the fastest and easiest way to do it, everybody. There are other methods to look at it. As far as I'm concerned, when you show work, we can always come up with some partial credit. Having said that, let me erase this. So inner quartile range is Q sub 3 minus Q sub 1, which makes it 14. 34 minus 2. We're going to continue, and we're going to see how we use technology. And remember, here's the formulas, here's the rank data, here's the value of X bar, S, Q sub 1 that we already have. So we use a TI calculator, for example, stat, clear list, put the list in L1, the data, and then you can type in the data in L1, L2, or L3, that's your choice. Then you go with the summary, stat, calculate, select one for one variable, and see what happens. So right here, here's the edit. You are going to edit the given information as it's given. You don't have, of course, it'll do the ranking and everything for you. So you put it, and then one variable stats, one variable stat, the list is L1, and then you just calculate. Since it has an arrow, you go down and you get all of them. Notice what you get. This is X bar. That's what we have here, X bar. This is S, and pay attention to S sub X because it gives us two answers. It gives us the standard deviation for the sample, or S sub X, or for the population, sigma sub X. Remember, we use Greek letters for population and Latin for sample. So that's the answer. And of course, with however many decimals they ask you. What else do you see there? You see the minimum, you see the maximum, Q1, median, Q sub 3, and all of the above have been calculated for you. If you use Excel, and here's the command for Excel, input and select the data range and click to sort it. So you put the data as it's given, and then you can sort it from A to Z or Z to A, from small to large or large to small. And then descriptive stat, you make the data analysis pack is added, data analysis, descriptive statistics, so on and so forth. You come up with, you see a case like this, you put in the information, and it gives you the answer. As you can see, the mean, the median, standard deviation, sample variance, range, mean, max, everything is there. Okay. Now, as far as Q1, Q sub 2, and Q sub 3, you can use the descriptive data to find Q1, Q2, Q3, and you put the ranges from one cell to another one. If you put 1, gives you Q1, 2 gives you Q sub 2, and so on. So having said that, so we're going to put quartile, D65 to D82. This is where I put those are the cells that contain the data. And I put 1, for example, and I get Q sub 1, and you can do 2 and 3 and so on. So that's pretty straightforward. As you can see, the information that we come up here is slightly different than what we have because various technologies, they use various methodologies to come up with that. I'm going to discuss that further later. Having said that, IQ scores have a mean of 100 and a standard deviation of 15. Find the coefficient of variance. Well, first, any application, any word problem, write the given. Mu, this refers to the entire population, unless specifically gives you a sample or sample size. Mu is 100, sigma is 50. Coefficient of variance. The coefficient of variation, or CV, describes the standard deviation relative to the mean and is used to compare standard deviation when the units are different. So sigma over mu, and that changes it to a percentage. 15 over 100, or simply 15%. Use the range rule of thumb to estimate the minimum and maximum usual IQ scores. So what are we talking about? Range rule of thumb indicates that mu plus minus 2 sigma, or x bar plus minus 2s, covers most of what we need. By most, I mean 95%, and that is considered the range rule of thumb. So in this case, mu plus minus 2 sigma would be 100 plus minus 2 times 15. This is 30, so it's 100 minus 30, which is 70, 100 plus 30, which is 130. So from 70 to 130 would be considered range rule of thumb, the usual estimate. So using Chebyshev's theorem, find what is the least percentage of those who will have an IQ score of 70 to 130. We already know that's within 2 standard deviations. So what is Chebyshev's theorem? According to Chebyshev's theorem, the proportion of values from any data set that fall within k standard deviations, in this case case2, of the mean will be at least 1 minus 1 over k squared, where k is a number greater than 1. K is not necessarily an integer. The idea is that this applies to empirical rule. Okay, they are symmetric, they are bell-shaped, but this one applies to everything. So having said that, obviously case 2, we've already established that from the previous part, and from 70 to 130, it's 60. 60 is 4 times 15, or 4 sigma. That's one way to figure. If they want you to figure it out, let me just quickly just show you in case. There are 2 ways to do that. You say 70, here's the mu, here's 130, and this distance, which is 60, this is, and you divide it by sigma, and that gives you k. Okay, and sigma happened to be 15, so there are 4 of them. That means 2 sigma on this side, 2 sigma on this side. Okay, all right. So 1 minus 1 over 2 squared, which is 1/4. 1 minus that is 3/4, so 75%. So at least 75% have an IQ scores as, between 70 and 130. All right. Using empirical rule, find the percentage of those who will have an IQ score of 70 to 130. Well, we have already established case 2. And again, quickly, I want to remind you again, if you need to find out 70, 130, you put the value of mu, which is 100. You have 2 ways to go. One way is that this is 30, so is this one. Now divide this by sigma, happen to be 15, and that gives you 2. So case 2, okay? Or just 130 minus 70 is 60, divided by 15, 4, divide 4 by 2, okay? So this entire thing is 4 sigma, okay? 4 times 50, in other words, 60, which is 4 times 50. All right, So in this case, case 2, we already know that. Let me erase my work, by the way. So according to the empirical rule over here, if you start from the mean and you go one standard deviation on each side, it covers 68% of the data, two standard deviations, 95%, and normally that's good enough, 95% of the data. And if you go further, it covers almost everything, 99.7%. So the empirical rule, also known as the 68, 95, 99.7 rule, is a statistical guideline that states where data falls in a normal distribution, which is bell-shaped and symmetric. It dictates that nearly all data falls within 3 standard deviations of the mean. 68% of data falls within 1 standard deviation of the mean mu plus minus 1 sigma. 95% of data falls within 2 standard deviation of the mean mu plus minus 2 sigma. 99.7%, almost everything, of data falls within 3 standard deviations of the mean mu plus minus 3 sigma. So if that is known, then we don't really have to worry about beyond that amount, 3 sigma. So case 2, therefore, we are in this vicinity, 95% will have an IQ score of 70 to 130. 70 to 130 or 2 standard deviations away from the mean. So that's pretty straightforward, everybody. Given the data, rank the data from small to largest and come up with the box and whisker plot. So we are going to rank it. Obviously, you notice as you go through them, number 3 is the smallest one, number 50 is the largest one. So you rank them, that's easy. All right. Now, in order to come up with box and whisker plot, we need 5 numbers. We need the minimum, maximum. We already have it. Also, we need all quartiles, Q1, Q2, Q3, and remember Q2 is the median. So you cut them in half, and right here is where the median is. So 15 plus 15 divided by 2, or simply 15. This is Q sub 2 or the median. There are different ways to calculate Q1 and Q3. I've already shown you one method. I'm going to repeat that and a different method. One is just cut the half, cut the bottom half and the top half, and the middle of the data is the submedian or Q1. To the top is the submedian for the second part, which becomes Q sub 3. And that's the fastest and easiest way, and that's absolutely fine. The other one is using the locator. N, we know it to be 14. You can count it. Okay, 1, 2, 3, 4, 5, 6, 7 here, 14. Locator is K over 100 times N. This is a percentage of it. That's the idea. So if we want Q1, that means 25%, the first quartile. So K is 25, or you can say this K over 100 is 25%, or simply 0.25. So either replace the K with 25, the entire thing with 0.25, or 25%. Gives you 3.5. Now, the methodology is you have to round it up, so it becomes 4. And the fourth piece of data is the answer, 1, 2, 3, 4. And the answer is 7. By the way, the method that I've shown you, this is the middle of the first part that works out. Happen to give you exactly the same answer. Now, for the Q sub 3 or 75th, and so Q sub 1 is 7. Q sub 3, now we use the same methodology over here, K is 75. And again, 10.5, we go up to the 11th one. So this was 7, then 8, 9, 10, 11. Okay, and that is 19. So now, we draw a number line, and then we basically make a point of those 5 numbers, the mean, the max, Q1, Q2, and Q3. Okay, mean, max, Q1, Q2, Q3. And then from Q1 to Q2 to Q3, we make up a box. The rest of it is a couple of whiskers, they call them. So looking like that. So the box contains Q1, Q2 or the median, Q sub 3. Then the whisker or just a line segment extending to the minimum from here, from Q sub 1 to the minimum, and from Q sub 3 to the maximum. That's how it looks like. Does this data set contain any outlier? Make sure to show the lower and upper fences on your graph. Q sub 1, Q sub 2, and Q sub 3 was calculated from the previous. So here's how the outlier works. You find IQR, you multiply it by 1.5, you subtract it from Q1, that becomes the lower fence, you add it to this one, becomes the upper fence. In other words, fence. The value for Q sub 1 minus 1.5 IQR and Q sub 3 plus 1.5 IQR are fences that mark off the reasonable values from the outlier values. Outliers lie outside the fence. I want to make sure we understand the concept. If you look at the data, something that is way too small or way too large is an outlier. But in math and statistics, we want to make sure there is no ifs and buts about it. So we go with the specific values. But sometimes it's easy to, recognize an outlier. But more specifically with numbers, well, IQR is Q sub 3 minus Q sub 1, which gives us 12. We have to multiply it by 1.5, which gives us 18. And so Q sub 1 minus 1.5 times IQR means 7 minus that, which gives us minus 11. The other one, Q sub 3, which is 19 plus 1.5 IQR, gives us 37. And obviously 50, let's just, okay, a little bit too fast. 19 and 18 is 37. So what it means, a number smaller than this, larger than this is considered an outlier. So when we look at this one, the only number is 50 because 50 is larger than 37. Also, we have the situation for an extreme outlier. A data is considered an extreme outlier in case they ask you. If its value is less than Q sub 1, instead of 1.5, we're going to put 3 minus 2 IQR, which is 7 minus 36 minus 29, or its value is larger than Q sub 3 plus 3 IQR. 19 and 36 is 55. So that's, remember, if you multiply this one by 2, you get the 36, or you multiply 12 by 3. So that's pretty straightforward. Outliers versus extreme outliers. All right, and now, are the data symmetric or skewed? How do we know that? So there are a couple of notes I want to make a point of. Number one, make sure the drawing is to scale. So if this is not to scale, then it really doesn't give us the proper answer. Note number two, skewed data show an uneven box plot, in which case the median cuts the box into unequal pieces. Longer part on the right or above the median indicates data is skewed to the right. Positive skew, that means the mean is larger than the median. Longer part on the left, so this is the key, or below the median indicates data is skewed to the left. Negative skew or the mean is less than the median. They all mean the same thing, okay? Also, note number three, sometimes the box may look even or uneven and even skewed to one side. However, the whiskers or the tails, those two line segments, on each side of the box may indicate otherwise. Therefore, pay attention to both. So here's the median. We're going to look at the left side and the right side. Here's the left side, everybody. Here's the right side. And clearly, the right side is what? Longer. So that makes it skewed to the right. So it is skewed to the right or positive skew, or the mean is larger than the median. It's very straightforward. All right, we're going to come up with the box and whisker plot. First and foremost, we have to rank the data. It is already ranked from smallest to largest. So this is the minimum, this is the maximum. We need those two pieces. Also, we need the median, Q sub 2 or median, and then Q sub 1 and Q sub 3. The median, you cut it in half. When you cut it in half, there is no number in the middle, so you have to add these two divided by 2. And that is your median. 86 plus 87 divided by 2 is 86.5. And as I mentioned, there are different ways to calculate Q sub 1 and Q sub 3. Here's an easier way, as I mentioned it before. This splits the list into two halves, the bottom half and the top half. Okay. Since the halves of the data set each contain an even number of values, the submedian will be the average of the middle two values. Okay. So right here, these two, and right here, these two. We add 79 and 80 divided by 2, we get 79.5. We add 87 and 94 divided by 2, we get 90.5. So we have everything. We have Q sub 2, we have Q sub 1, we have Q sub 3, everything is there. So here's the 5 numbers that we need. And again, in number line, very carefully, okay, set up. And then here's the minimum, here's the maximum, here's Q1, Q2, Q3 must be to scale. So this is the box, and those are the whiskers or the tails. So what do we notice? Here's Q sub 2. And it appears that the left and right are the same. So data is almost symmetric, which means normal or bell-shaped. Okay. Now, couple of things. They then ask for IQ sub IQR is Q sub 3 minus Q sub 1 is 11. Outliers Q sub 1 minus 1.5 times IQR, 1.5 times IQR is 16.5. So 79.5 Q1 minus that, and Q sub 3 plus that, 63 and 107. Extreme outliers, if we go with 3 times that, are 46.5 and 121.5. I just wanted you to see that in case. Also, if n is odd, in this case, when we have no number in between, that's even. Clearly, there are 8 pieces. But what happens if it's odd? So what I did, I used the same thing and I added some number. Okay. Now the median is the number in the middle, is 87. Okay. Now the bottom half and the top half, in some cases they include the median, in some cases they don't. Okay. It's a better methodology to include it. So sorted lowest half, as you can see, the one in the middle of the lowest half and 87 is included is 80. Sorted highest half, including the median, 87 is there all the way to the end, and the answer is 94. So Q sub 3 is 94. So that's the method that is also used. Again, in some cases, they drop the median and they look at this bottom half, that bottom half. Okay, I want you to be aware of that. If the mean of a set of data is 23 and 12.6 has a z-score of negative 1.3, then the standard deviation must be. Well, without any paying attention to this, let's write the formulas. First and foremost, what is given? Mu is 23. X is 12.6. The z-score is negative 1.3. And either z is x minus mu over sigma or x minus x bar over s. So I hope you recognize that if you do the cross product, it's the same as sigma and z being interchanged. That's the same thing. And since we want to find the standard deviation, we want sigma x 12.6 minus mu 23 over z negative 1.3. The answer is 8, and that makes it part D. So that's pretty straightforward. Find the z-score for each student and indicate which one is higher. So art measure short AM, here's the X, that means the value that the student had. X bar, the mean for the class, is the standard deviation, and this is theater measure or TM. So let's calculate the z-score for each one using X minus X bar over S. For this one, it's 46 minus 50 over 5, and we end up with negative 0.8. For this one, 70 minus 75 over 7, and we end up with this number. So clearly, both of them are negative. By the way, when the z-score is 0, that means the score is the same as the score for the average of the class. If it's positive, that means larger than the average. If it's negative, that means below the average. So having said that, both of them happen to be below average, but this is more negative than this one, so this is higher. And the answer is C. The theater measure has a higher score than the art measure. This one, okay? If the 5-number summary for a set of data is 0, 3, 6, 7, and 16, then the mean of this set is, well, we have no idea. There is insufficient information to calculate the mean. We have no idea. Why? Because x bar is summation of x over n, or mu is summation of x over capital N. Add up all values in the data set and divide by the number of values. We need all data to do so. We don't have it. Which of the following is true? Well, part B. Why is that? Part B, because D stands for the deciles, measures of location that divide the data into 10 equal parts. Percentiles, measure of location that divide the data into 100 equal parts. Quartile, measures of location that divide the data into 4 equal parts. Therefore, D5, P50, and Q2 are the same according to the definition that we have here. A student received the following grades: an A in statistics, which is worth 4 units or 4 credits. F in physics, worth 5 units or 5 credits. B in sociology, 3 units. B in literature, 2 units. D in tennis, 1 unit or 1 credit. And we know A is worth 4 points, B is worth 3 points, D2, D1, and F0. So what is the GPA for the student? This is how the grade point average is calculated using the weighted mean. When different X data values are assigned different weights W, we can compute the weighted mean. To find the weighted mean of a variable, multiply each value by its corresponding weight and divide the sum of the products by the sum of the weights. So first, to understand the concept, okay, if you received an A in a course that is worth 5 units, okay, versus a course that is worth 2 units, they are not the same in that sense. So having said that, we are going to use this formula. So let's go with the table. So we have A, F, B, B, D, and the first one is 4 units or 4 credits. F is 5, B and B 3 and 2 and 1. So I hope you see this comes from those. A is worth 4, F is worth 0, and so on, as it was mentioned here. So X bar is, you multiply these two columns, 4 times 4, plus 5 times 0, plus 3 times 3, plus 2 times 3, plus 1 times 1. That would be the numerator. The denominator is the weight, in this case, the numbers that we have here, the number of units, 4, 5, 3, 2, 1, add them up. We get 32 over 15, or 2.133 as far as the number of decimals, whatever they ask you. If they did, then you round it accordingly. Given the data set, find the value that corresponds to the 75th percentile. So how do we find that? Again, we go back to that locator that was mentioned. First, you have to rank the data. The smallest is 10, the largest is 72. Rank the data. You want the 75th percentile. N is 8 because we have 8 pieces of data. And the locator is L equals K over 100 over N. Simply, in this case, means 75. Or just replace the entire thing with 0.75 or 75%. So we do that. When we get a whole number, we have to go in between that one and the next one. So 6th and 7th number. 1, 2, 3, 4, 5, 6, and 7. 44 and 56, we add them up, divide by 2, we get 50. That's the methodology. For 30th percentile, so we're going to use the same thing here, replace the K with 30 or the entire thing with 0.3, for example, and we end up with 2.4, and we must always round up in this case. So the third piece, 1, 2, 3, number 15, as you can see. Find the percentile corresponding to number 44. By definition, number of values less than 44 divided by n, that's the percentile. So if you look at 44, okay, how many are less than that? 1, 2, 3, 4, 5. So 5 over 8. Change it to a decimal, 0.625, or now rounded about P63, because normally with the percentile we go with 2. But you can write 62.5, but normally they wanted a whole number here. Using range rule of thumb, estimate the standard deviation. As you recall, if we start from the mean and we go 2 standard deviations on each side, following the empirical rule, that covers about 95%, and that's the range rule of thumb. Therefore, we are talking about the mean on this side is 2 standard deviations, on this side is 2, the total is 4, which gives us the following. Recall, range rule of thumb, mu plus minus 2 sigma or x bar plus minus 2s. Range rule of thumb for estimating a value of the standard deviation. To roughly estimate the standard deviation from a collection of known sample, data use s equals range divided by 4. This 4 because 2 sigma on the left, 2 sigma on the right, so that's why divided by 4. So, or the range is maximum minus minimum. In this case, maximum is 70. 2, minimum is 10, and divide by 4, we get 15.5. The following data representing numbers of keyboards assembled for a sample of 25 days in a company. These are given. Construct a frequency distribution table with 4 classes. Normally, when you're on your own, you decide how many classes, but as far as the homework is concerned, normally you are given the numbers. So the very first thing is to put this in order from smallest to largest. We're going to rank the data. That should be easy to do so. Now, how many classes we need for? So we want to estimate the width that we need. So we are going to divide the range by the number of classes. The range, as you can see, is 56 minus 41. And how many classes? 4. Let's divide by 3.75. So the width is 3.75. And to be on the safe side, you really want to round it up. And you want to round it up for two reasons. Number one, you want to make it easy to set up your classes. Number two, you want to make sure the bottom as well as the top value, they're all covered. So from smallest to largest. So that you got to be very careful of. So where do we begin? Lower limit of the first class. Some starting point is a convenient number less than the smallest number, the smallest value such as 41. So you can start with any number that you want as long as it covers the entire thing. So the lowest, the minimum value is 41. So you can start from 41 or something smaller than that. I highly recommend you try 40, see if it works. When I say does it work or not, because 3.75 went to 4, we want to make sure when we are done with that, the maximum value of 56 is also covered. So having said that, what do we put here? We said the width is 4, right? So that means if you go down with the first, the lower limits, we just add 4. So 45, 49, 53. Okay. Now, what goes here? Do you remember that we said if we want to go this way to find the width was what? Upper limit minus lower limit plus 1, right? And so we know the width is 5. Upper limit is missing. Lower limit is 41 plus 1. And we get 44. So the first one is 44, the upper limit for the first class, and then you add the width of 4. That's how you come up with the answer. This was 4, by the way. Okay. All right. And so we start counting from 41 to 44. We have 1, 2, 3, 4, 5. So let me erase my work. So 41 all the way to 44, we have 1, 2, 3, 4, 5. So this is number 5. The next one, 1, 2, 3, 4, 5, 6, 7, 8. And you can figure out the rest. And that is your frequency distribution table. Use the data to find the mean. To find the mean, just add them all up. From the very first one all the way to the last one divided by the size, which is 25. So x bar is summation of x over n, 45 plus 52 all the way to the end. Add them up, divide by 25, and that gives you an average of 48.40. That's an exact mean or average. What about an approximation? If the frequency distribution table is given and you don't have access to the data, that gives you an approximation, which is the following formula. X bar is summation of f x sub m divided by n. Okay. Remember, frequency distribution table, FDT for short, does not give us every piece of data. So we use x sub m, which is the midpoint of each class. So what is the midpoint? Lower limit and upper limit, add them up, divide by 2. So in this case, 41 and 44 divided by 2 is 42.5. That's the way to do it, everybody. That's how you calculate the midpoint for each class. Now, you can calculate the midpoint here as well, but there is no reason to. We already know the width is 4, so one easy way, add 4. So the next one is 46.5, add 450.5, add 454.5. So you have those. And to find the average using this, you multiply these two columns, 5 times 42.5, 8 times 46.5, 8 times 450.5, 4 times 54.5, add them up, divide by the size, which was 25 days. And are the two means reasonably close? Well, here's the actual value, the exact value. Here's the approximation. And not having each piece, that is actually pretty good. So yes, they are reasonably close.